Hi everyone, today you're going to watch a short video, and in this video I'm going to show you how you can find solutions to systems of equations by graphing. So what you're going to see on the top of your notes is the number of solutions of systems of linear equations. So your notes look like this at the top, and you can see there could be three things that happen when we graph. The lines could intersect and cross, the lines could be parallel, or the lines could end up being on top of each other. So I'm going to go to this screen, and so then what your job is to do now is everything that I have written down. Please make sure you write down in your notes so that you can use them when you do your independent practice. So number of solutions. First of all, if you look at the equations, they should have different slopes. And so if the equations have different slopes, the lines will intersect. And yesterday we talked about how that intersecting is called the point of intersection. I call it POI. So at this point would be a solution to both lines. So the solution of this line would be 1, 2. Over 1, up 2, there's your solution. Let's fill in the rest of our notes. The lines intersect, so there is one solution. So if they intersect, you'll only see it crossing in its path in one spot. Okay, the second one, if you have the same slope, both equations have the same slope, but they have different y-intercepts, this is what the graph would look like. So you can tell here, these two lines both start at different points. This one has a y-intercept of -1. This one has a y-intercept of 1. The slopes are the same, up 1 over 1. So same slope, different y-intercept, and you can see that these lines are parallel. So if they are parallel, there will never be a POI, a point of intersection. So therefore, there will be no solutions to these problems. They will never cross. The third one. If you have the same slope and the same y-intercept, you end up drawing a line on top of that same line. As you can see here, I have that black line, and then on top I drew the purple line. Exact same line. So what happens when you have the exact same line? Well, the lines are the same. Sometimes it's called coinciding, that you will see they are coinciding lines. You might want to write that word down. Maybe I will do that for you. Let me see here. I know this is interfering with the screen. So this right here, I am just going to add under same, I'm going to add the phrase coinciding. So feel free to add that in too, it means the same thing. And if they lie on top of each other like this, it simply means that there's infinitely many solutions. No matter what point you pick on this line, they are both going to be solutions to both equations. All right, so that's all that's to it, simple. So let's take a look at some examples. So here's your first example on the bottom part of your notes. It does say graph each system. We're not going to worry about graphing right now. Just want to look at our notes and see what we can identify. So here's our first problem. So if we look here, look at your slope. What can you tell about the slopes? We have the slope of -1/3 and 2. So if you go back to your notes, are the slopes the same? The answer is no. Different slopes, same slope, same slope. Different slopes, automatically what's going to happen? They're going to be crisscrossing lines. So the answer should be intersecting lines. Let's take a look here. And you can see slope of -1/3, slope of 2. Different y-intercepts. Therefore, when you graph it, this is what it would look like. The two lines would cross each other. I graphed the red line, I graphed the blue line. That green point there is the point of intersection, the POI, and so that would be the solution. So the solution would be at 0, -1, -2, -3, and go down 1. So -3, -1 would be the solution to this system. Okay, next problem. Here are my equations. You see that we have the slope of 1/4, slope of 1/4, same slopes, y-intercepts, plus or positive 2.5 and minus or 0 or negative 0.5, different y-intercepts. Going back to our notes, different slopes, nope, they're same slopes. So same slopes, different y-intercepts, or same slopes, same y-intercepts. Well, these were definitely different y-intercepts. So different y-intercepts means that they are going to be parallel lines. So let's take a look, see what that looks like. So here's my slopes. They're the same. The y-intercepts are different. One's positive, one's negative. If I was to actually graph these, I would see this is the red line, here's the blue line. They are definitely parallel lines, and there is no solution to parallel lines. They'll never have anything in common. All right, the third one. What you notice here is we have a little bit of a problem. The last ones have been really easy to do. This one, you can tell none of these equations are written in slope-intercept form, so we can't identify their slopes or their y-intercept until we change them and put them into intercept form. So I'm going to go on to the next page, and go ahead and try it on yourself if you can. Pause, and then we'll go to the next page and we'll walk through it if you are still struggling. So here's a little bit of a mess, so I do apologize a little bit for the chaos. So the very first equation here, x minus 2y equals 2, you're going to see right in here. So again, how do you rewrite an equation? I make my boxes. You can do the undo method on both sides, or you can do the box method, whichever you find easiest. I'm going to demonstrate the box method because I think that's the easiest. So y's go on one side, x's and numbers on the other. So my y's go in the y box, so negative 2y comes down. X crosses the line, so you flip the sign, it becomes a negative x. And the 2 is just a number and stays on that side. Now we have to get rid of, we got to get y by itself, so I've got to get rid of the negative 2. So I divide by negative 2, divide by negative 2, and you can't see behind my video, this is also divide by negative 2. So when I simplify, I get y, negative 1 divided by negative 2 becomes positive 1/2 x, and positive 2 divided by negative 2 gives me negative 1. So there's my first equation. So I can see that right above here. So I have a slope of 1/2 and a y-intercept of negative 1. Now I took the other equation, threw it down here, did the exact same technique. Y is in the y box, x is in the x box. If you cross the line, flip the sign, numbers in the numbers box, divide to get the y by itself, and my equation ends up being y equals 1/2 x minus 1. So I write that up here, and you can tell the slopes are the same and the y-intercepts are the same. So when the slopes are the same and the y-intercepts are the same, based on the notes, go back if you like, but those would be the exact same line. So coinciding line is what's used in this example. If you even want to write in parentheses same lines, so you know they mean the same thing. But in the picture here, you can actually see that these lines would actually fall right on top of each other. So because of that, they have infinitely many solutions. All right, so those are my examples. So we have a couple more problems. So now let's try some on your own, just by looking at the graphs this time. So in this graph, what kind of solution do we have here? Go ahead and pause it, try these 3 problems, and then come back and see how you did. All right, guys, welcome back. You can tell this is intersecting. So the point of intersection would be right here in this area. So that would be a positive 3, positive 4. So if you said, oh, I lost my little, there we go. So if you said positive 3, positive 4 for your solution, you're absolutely correct. Good job. Okay, number 5. Pause it if you didn't do this problem yet, or let's go ahead and look at the answer. All right, welcome back. Here are the answers. This is 2 parallel lines. 2 parallel lines will never cross, so they'll never have a POI, a point of intersection. So therefore, you should have said no solution. And our last problem. You see the 2 lines on top of each other. Therefore, you know that every single point on this line matches with the point on the other line. So therefore, you should have said infinitely many solutions. So that's all that's to this lesson, ladies and gentlemen, is just being able to identify how many solutions they have from equations or from graphs. So your assignment is to complete this table. You'll notice it starts off with everything in slope-intercept form, and towards the end here, you're going to have a couple problems where you will have to rewrite this problem in order to be able to identify no solution, one solution, or infinitely many. The next part will be the graphing part, looking at the graphs and determining if there is a solution, what is the solution, or is it infinitely many, or no solution. And that is your independent practice. All right, bring that to Mrs. Meyer when you are done, and we'll take a look and see how you did. All right, see ya.